Welcome to the first video of the year on sequences and summation notation, Chapter 10, Section 1. First of all, we'll just define what it means to be a sequence. And basically a sequence, there could be two types of sequences. There could be an infinite sequence, or there could be a finite sequence. An infinite sequence, basically a function whose domain is the set of positive integers, and it goes on forever and ever. So for example, 1, 2, 3, 4, 5, 6, and so on. That is a infinite sequence. Or the set of even numbers like 2, 4, 6, 8, 10, and so on. That is an infinite sequence. The most famous infinite sequence is what's called a Fibonacci sequence. That's where the first two terms are 1, and then every term after it is the sum of the previous two. So the next term, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, 21 plus 34 is 55, and so on. It will just keep going on. The next one will be 89, and so on. It keeps going on forever and ever, but that is what's called the Fibonacci sequence. So if anybody said, like, the number 13 is a Fibonacci number, that's what they mean. It's part of the Fibonacci sequence, where you're starting with the first two terms of 1 and then adding the previous two terms to get the next term. A finite sequence only has a specific amount of terms. So for example, if I said the first 5 even numbers, that's a finite sequence because that would be 2, 4, 6, 8, 10. That's a finite sequence because it has a specific amount of terms. Writing the first 4 terms of the sequence, so basically n is going to be the number of term. So for example, if you're finding the first term, that means you put 1 in for n, and you get 3 times 1 is 3 plus 4 is 7. And so you do the same thing with 2. So you get 10. You do the same thing with 3. And then 4. And there are your terms, 7, 10, 13, and 16. Next one, you put 1 in for the number of term. So you get negative 1 over 2. So then you put in 2. And then you put 4 in for n. And you get 3 to the 4th is 81, minus 1 is 80. So your terms are negative 1/2, 1/8, negative 1/26, and 1/80. Those are your 4 terms of the sequence, the first 4. A recursion formula is a formula that defines a sequence as a function of the previous term. So for example, here you want to find the first 4 terms of the sequence, and n is once again the number of term, so it gives you the first term. So to find the second term, that means you're going to put the 2 in here, so that means basically you're going to take 3 times the first term plus 2. Well, the first term is 5 plus 2. So 3 times 5 is 15, plus 2 is 17. So for the third term, we're going to go 3 times the second term. So the second term was 17 plus 2, so 51 plus 2 is 53. And for the fourth term, we're going to go 3 times the third term plus 2. So 53 times 3 is 159, plus 2 is 161. So the four terms are 5, 17, 53, 161. So a recursion formula, you use the previous term to find the next term. So you're not putting in the number of term, you're putting in the actual term, the previous term. Factorial notation. So factorial notation is the product of a consecutive positive integer. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. So basically, whatever factorial is, you multiply all the numbers before that. So this is 120. So using it to find the terms of a sequence, so like the first term, here 20 over 1 plus 1 factorial. 2 factorial is still 2 because 2 times 1. So then the second term, you put 2 in for n. So you get 20 over 6, which is 10/3. And then the third term, well, 4 factorial is 4 times 3 times 2 times 1, which is 24. So it's 5/6. And then the fourth term, so that's 5 factorial on the bottom, which is 120. So when you reduce that, you get 1/6. So the terms are 10, 10/3, 5/6, and 1/6. All right, next, this one wants you to evaluate. Well, remember, 10 factorial is 10 times 9 times 8 factorial, because you're just going to go all the way down to 1. So this is 2 factorial, 8 factorial. So you can cancel the 8 factorials. So you have 10 times 9 is 90 over 2 factorial, which is 2. So that gives you 45. So here, n plus 1 factorial means it's n plus 1 times n times basically n factorial. So the n factorials here will cancel, and you're just left with n plus 1. Because think of n, like if n was 9, so it would be 10 factorial over 9 factorial. So it would be 10 times 9 factorial, and you could just cancel the 9 factorials. It's the same concept, except now it's just an n instead of a number. Summation notation. So, summation notation, this means you're going to add the terms that you find. So here's the formula. This is the upper bound, and this is the lower bound, meaning the lower number that you put in. So, to give you an example, here, starting with the number 3 and ending with the number 5, we're going to put numbers into this formula and then add them up. So 2 to the third minus 3 gives us 5. 2 to the fourth minus 3 gives us 13. 2 to the fifth minus 3 gives us 29. Those are the 3 numbers that I put in, 3, 4, up to 5. Then I add the terms. And I get 47. So 47 is the sum in this case. The last thing we're going to do with that is we're going to go backwards. So here we have a list of terms that we're adding, and we're going to write it in summation notation. Well, we're going to start with 1, because if you notice there's a pattern. All the numbers 1, 2, 3, up to 9 are squared. So I know the last number is 9, and I'm taking whatever number I put in, so I'll put an I, and I'm squaring it. The last one here, I'm starting with 1. Now I'm ending, it says n minus 1, so I'm ending with n. Because if you notice, you have 1, like 1 over 1, and then you have 1/2. And then you have 1/4 and 1/8, and it kind of gives you the thing here, 2 to the n minus 1. So basically you're going 1 over I to the n minus 1. And you can test it out. Like if you put in 1, well 1 minus 1 is 0, I to the 0 is 1 to the 0 is 1, 1 over 1 is 1. If you put in 2, 1 over 2 to the 2 minus 1. So 1 over 2 to the first is 1/2. So it all works. So 1 over 2 to the third. Sorry, this is going to be 2 to the I minus 1. Like this. Sorry. So 3 minus 1 gives you 1 over 2 squared. So this gives you the pattern right here, that it's 2 to whatever minus 1. In this case, I'll call it I. 1 over 2 squared is 1/4. And so on. If I put 4 in there, 1 over 2 to the third is 1/8. All right. I hope this video helps, and feel free once again to ask questions in class, and we'll talk about it more next class. Hope your first day of school went well, and I will see you tomorrow. Have a good evening.